Alright, slightly more complicated partial fraction decomposition this time. Our goal is the same. We want to rewrite this rational polynomial as a sum of two or more partial fractions. So, to do that, same idea as before. Go ahead and factor that denominator as much as you can. So leave the numerator the same for now. Looking at that denominator, we can factor out an x squared from both of those terms, and we get x squared times the quantity x plus 4. And just like before, we're going to split that up into a product of fractions, but it's going to look a little different this time. Because we're dealing with a cubic function in the denominator, we're going to get 3 partial fractions. So, just like you would think we would get, we're going to get x squared as the denominator for one of them. We're going to get x plus 4 as the denominator for another one. And we're going to get x as our third denominator, which you can see probably is coming from that guy right there. It's not as straightforward as to see why we get that, but we can talk more about that later. So, let's keep going for now. We're going to get an A numerator, B numerator, and C numerator, all values that we don't know. So, let's go ahead and use our cover-up method and say, if I plug in these values, what do I get? Blah, 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 blah. But before I can do that, let's get rid of these ugly denominators. So, just like before, focus on this bit right here, and let's multiply by that denominator on all of our terms. So go ahead and do that now, pause it, and then check back in a minute, see if you did the same thing that I did. So you should be seeing something like this. Again, just like before, we've got the same thing in the numerator as denominator on the left side, so we're going to be left with just our numerator. Again, that was the goal, so we get 3x plus 7 over there, equal to, well, when you distribute x squared times x plus 4, that whole quantity, distribute that over to our first fraction. Notice we're going to get 1x canceling out from that denominator there. So we're going to be left with a times the quantity x times x plus 4. Plus, let's look at our middle fraction there. Now notice our x squareds are going to cancel each other out. So we're going to get plus b times x plus 4. And then finally we'll get plus c. Notice our x plus 4s are going to cancel out, so we'll get cx squared. Just like that. Let's go ahead and simplify this a little bit. Actually, let's not. Let's just go ahead, plow straight through and start going with our cover-up method. So to do that, we want to be clever with the x values we choose to plug into this equation, because since it's an equation, it should be true for all x values. So let's go ahead and substitute some smart values into this equation. First off, notice that we have this x plus 4 factor in both of those pieces right there. So let's substitute in an x value of -4, because then we can figure some fun stuff out. So do that, we're going to get 3 times -4 plus 7 on the left equals a times -4 times -4 plus 4 is 0. So that whole term is going to disappear. And then look at our b term. b times -4 plus 4, well, that's 0. So that whole term goes away. So we're going to get equals c times -4 squared. Sweet! We can figure out what c is. Well, 3 times negative 4 is negative 12 plus 7 equals c times negative 4 squared is positive 16. So we get negative 5 equals 16c, and we find that c equals negative 5 over 16. One value done. Let's be smart again and find another term. Well, the other clever x value that we can substitute in is x equals 0. And let's see what happens. Well, we're going to get 3 times 0 plus 7 on the left equals a times, I'm not even going to write this because, look, plug 0 in for x there and we get 0 times, doesn't matter what that is, it's 0. 0 times a is 0, so that term is gone. Our middle term, we're going to get b times 0 plus 4 plus c times 0 squared is 0, so no c term either. And we can simplify this. We're going to get 7 equals 4b, and so b equals 4 over 7. Second term found. Third one, not quite as easy to find because we are kind of in trouble. We don't have another value, an x value, that we can just substitute in and have some things magically cancel out. So let's choose the next easiest x value for us to work with, which, in my opinion, is 1. So let's substitute in and see what happens. We're going to get 3 times 1 plus 7 equals, I'm going to move this because I'm running out of room, so give me a sec. Alright, I found myself some room. So we were substituting 1 in here, so we got 3 times 1 plus 7 on the left equals a times 1 plus 4, close my parentheses, plus b times 1 plus 4 plus c times 1 squared. Simplify it out, we're going to get 10 on the left equals 1 plus 4 is 5 times 1 is 5 times a is 5a plus 1 plus 4 is 5, we get 5b plus 1 squared is 1, so we get c. But don't forget, we know what a and we know b and c, so let's substitute those values in and start simplifying to find a. So 10 equals 5a plus 5 times b. Well, b is 4/7, so we're going to get plus 20 over 7 plus c is negative 5 over 16. And I'm realizing that I have to pause real quick and make a correction because b is not 4/7. B should be 7/4. Mr. Reed apparently is not so good at being careful late at night. So jump back up here where we were solving for b. Look right there. We had 7 equals 4b. So divide by 4 on both sides, and you should get b equals 7 over 4. Not 4 over 7. My bad, y'all. So let's go ahead and fix this problem down here where we are using it now. Apologies, apologies, apologies. Okay, so let's fix this. That term is all gummed up. We have 5 times b, which is going to give us 35 over 4 from the 7 times the 5 right there. Cool. We should be back on track now. Okay, so let's simplify this even more and solve for a. Now, you can do this however you want. How I'm going to do it is I'm going to multiply both sides of this equation by 16 to get 160 equals 5 times 16 is 80. So I'm going to get 80a plus 35 over 4 times 16 is going to get me 140 plus negative 5. And I just wanted to get rid of my fractions to make my life easier. So we're going to get 160 equals 80a plus 135. So we're going to get 160 minus 135 is 80a equals 25. So a is going to equal 25 over 80, which should reduce to 5 over 16, and that is our value for a. So we have a, b, and c. So just like in the other problems, we're going to wrap this all up by actually writing our partial fraction decomposition. So do that now and come back to me when you're done with that. So let's go ahead and finish this problem up. We should get 5 over 16 over x plus our value for b, which was 7 over 4 over x squared, plus our value for c, which is negative, so I'm just going to write it as minus 5 over 16 over x plus 4. And again, that whole thing should be equivalent to what we started with, which was 3x plus 7 over x cubed plus 4x squared. 3x plus 7 over x cubed plus 4x squared. We're saying these are equivalent. And again, as before, your challenge is to go ahead and actually find a common denominator and then take this decomposed fraction and write it as a single fraction. Again, prove that what you just did actually works.